Hey there, Tony Verbsky here. This is a lecture over section 11.1 from our trig book, The Law of Sines. You will like this concept, except in MML, we're going to have to be pretty good on our calculator. Everybody likes law of sines, everybody likes law of cosines. It's just good crank and grind stuff. Now, the proof of law of sines is basically we do it in our high school. It's pretty elementary, combination geometry and algebra, Pythagorean theorem. It's basically pretty easy to do. So what we're going to do is I'm going to give you the formulas and we're going to just move. So here's the way it works. This is what I refer to as my angle finder formula, and this I call my side finder. Whoa. Side finder. So when I want to find the side, I write down the lower one. When I want to find an angle, write down the upper one. What's easier? Well, finding sides is easier. What you need is a pair. What do I mean by that? Let's spell pair, not like pain, that pair. You need an angle A and a little a, or you need an angle B and a little b, or you need an angle C and a little c. So let's start off with the easiest problem I have. So if I go A is 31 degrees, and call that 11, and I call this 29 degrees and decide to call it, I can call it B or C. Let's go with B. Force this to be little b. That's by default C, little c. This is the easiest case. First of all, do I have a pair? Yeah, I have an A and a little a, therefore law of sines. Clearly, I know all three angles because 31 degrees plus 29 degrees plus angle C equals 180. Angle C is 120. There we go. Now all we need is little b and little c, so we go side finder. Side finder is sine of your pair. Oops, side finder. Side on top, angle on the bottom, equals little b over sine b. And then just multiply both sides by sine 29, which you just cross it up. Same with this, c over sine c, just cross it up into there. So bottom line, the way it's going to work, forgive me, I don't have my calculator fired up. Hopefully, okay, browse. Hopefully it actually finds it. There we go. Open it up, finish, and it's good. Let's see if we can get it on top. Life is great. Now what we got is 11 times sine 29. How about let's go sine 120. Let's do C first. Help if you type in sine. I never check the mode. Divided by sine 31. Obviously the mode's probably wrong. Second quit, re-evaluate, and I get C to be 4.906396. And let me pause. And I'm back, had a little sun glare going. And then if you go and reselect, you're going to cross up the sine 29, replacing it with the sine 120. So just go to here and go 2, 9, delete. Uh-oh. Sorry about that. The last one's wrong. Didn't see the divide sign. I had so much glare. I did not see that I screwed up the last calculation right here. You can see I need a divide sign right there. Second, insert a divide sign. Mode. Ooh. Oh, man, I'm struggling. Let's try this again. Third time's the charm. Second, insert a divide sign. There we go. C. 18.496. Here we go. Now we get after it. You go back and you select the successful calculation. And finally, you change the 120 to a 29. Hit delete, confirm, and we get 10.35439.142. Come on, MML. Try to get me. I'm running like 8 decimals deep here. Life is good. Okay, so if I give you a pair and another angle, law of sines is really fun. There's no real big issues. Okay, the worst word in all mathematics, recall. Well, the sine graph looks like this. Let's go back to talk about inverse sine being a function. We scribble like this, and therefore inverse sine, see, this is pi over 2, this is 1, 1, pi over 2, flip the points, flip your 0, 0, negative 1, negative pi over 2, inverse sine looks something like that. Let me try this. 1/2 sine of 30 is 1/2. Yep, thought I flexed it the wrong way. So, by the way, very few people actually remember what inverse sine looks like. As you can see, I just checked. Let me see. There we go. Almost got it. Yeah, kind of looks like tangent, only it stops. There we go. 1/2, 30. Yep, I got, that's what it looks like. Now, sine of theta equals a number between -1 and 1. This angle, if you want to talk about sine inverse, can only be from minus pi over 2 to pi over 2. The restricted version, the scribbled version. Normally the domain of sine is all real numbers, but if you want to use an inverse, this is sine inverse x. Now if we take sine inverse of both sides, theta equals sine inverse of a number. Well, these numbers have to be between -1 and 1, so don't plug in 2. It won't make sense. And these angles, well, they're in the same spot. They're from minus pi over 2 to pi over 2. Therefore, for inverse sine, and similarly inverse secant and inverse tangent, I always go theta could be here from minus 90 to 90, and running from there to there, or pi over 2 negative 2 pi over 2. Just have to remember that the answers for inverse sine can only lie in quadrants 1 and 4, but 4 is the weird one, negative, from negative pi over 2 to pi over 2. So, bottom line, with respect to triangle work, since you can't have negative angles, you're going to be lying in here in quadrant 1. But at the same time, there's this other stuff going on, because if we originally start with sine, and somebody's saying sine equals something, there's 2 answers before 180. So what's going to happen is we're going to have a sign problem, and we know there's two answers, but at the same time, we know when we take inverse sine, you're going to get one answer in the first quadrant or one answer in the fourth quadrant, and maybe we should do this. We should go only one answer. And the reason why there's only one answer is because we scribbled the other function so much that it only has one answer. So on the hard problem, what I'm trying to say is you actually got to know what you're doing. And I'll show you how to do it. So bottom line, if you use inverse trig, you got to know that it's going to give you one answer, but you sitting there knowing there's two answers, and you got to learn to consider the second answer. So it's the only thing hard about the first two sections, by the way. So here we go. If I give you a pair, 31 degrees, little a is 11, and I give you another side, like 13, we got to call it something. Let's call it B. Big B, therefore little c, big C. Now I got three things to solve for, but I can't find the other angle. So bottom line, I'm going to find this angle so I can find the other angle. And I'm going to proceed blindly. I'm going to go sine 31 over 13. Since I'm using an angle finder, I put the trig function on top. And that would be a mistake because you got to put the pair. Sine 31 over 11 equals sine B over 13. Now you multiply both sides by 13 or cross it up. Now this isn't as easy as the last time. You actually got to get this number and actually look at it, because it may turn out that there's no possible triangle. And I get 0.608, but don't lose your decimals. Now, we know sine looks like this, and there's two answers before 180, therefore both of the answers could be possible. But we know when we do inverse sine, you only get one answer. Always go, if this is negative, in my opinion, always make it positive, because you're the one that decided to use an inverse. We can find a reference angle instead. So making sure you're in degrees, inverse sine of the last answer, I get B1 to be 37.494 degrees. Now watch this. Stow alpha Z. So let's call this guy Z. Now sine is positive in the first and the second. Therefore there's an answer here and an answer there. This answer is this, and that was Z at 37. To find this answer here, you got to go, because we know this is 37.494 because it's a reference angle, we go B2 is 180 minus Z. So we go 180 minus alpha Z. Kept all my decimals. 142.505. Hey, let's store this in W. Stow alpha W. Now the bad thing about this is we're getting two triangles, we think. So let's write down what we have. Little a, it's 11, big A, 31. Then we got a little b, which is given, unchanging. But we got a B1, which is 37.494. given us a C1, and the C we don't know. This plus this equals this. So let's do that. 31 plus B1, which is Z, alpha Z, minus 180 times a negative 1 is 111.505. Let's store that in U. Stow alpha U. Now, before I continue, this is the hard part. We got another triangle going. B2 is 142.505. And you always go, please go over 180 degrees. Because if it does, then you don't have a triangle. Unfortunately for us, 142 and 31 doesn't go over 180, so we got this two triangle case that nobody's a fan of. So this plus this minus 180 times negative 1 equals this. So what is B2? B2 is W. So 31 plus alpha W minus 180 times the negative 1 is a C. Let's stow that in the V. Stow alpha V. And we get 6.49. 6.494. Let's call that V. Now the only thing left is, well, little c1 now and little c sub 2, because the c's are going to be different. You want a side finder, so you take your pair, put your side on your top. C1 over sine C1 and C2 over sine C2. And you just cross this up, cross this up. Now remember, C2 is V, and remember C1 is U. So here's your calculation. 11 times sine alpha U divided by sine 31, 19.87, and that's C1, 7374, and then re-execute, replacing the sine U with the sine V. .415612417, and I am ready for not Mathematica, sorry, that's another program I use for calculus 3 and differential equations. I mean my math lab. So, two triangle case. You just hope I don't assign very many of them. Maximally, you want to do one or two of these things. And then on a final exam, let's make sure that me, the instructor, doesn't ask one. You know, I'm going to go out of my way not to ask the two triangle case. What's left? Well, the one triangle case and the no triangle case. So here we go. Let's see if I can find one. Okay, one triangle, looking through the book. Maybe I got some good ones in there. So looking for a side and one answer. Side, one answer. Side, one answer. Ooh, I should find one with seconds. This book is terrible about that. Here's one. Don't know how it's going to turn out. It's actually question 51 in the section. A 38 degrees, 40 minutes. Nothing worse than when the book uses old school. Little a 9.72 kilometers, little b, 11.8 kilometers. There's a pair, obviously, law of sines. Going to look for the big B. There will most likely be a B1 and a B2. We're hoping to eliminate the B2 case. If I happen to work another double triangle case, it definitely doesn't hurt you. Learn how to use a calculator in degrees, minutes, seconds is probably worth it here. So I'm going to go get angle B, which means I use the angle finder. And you cross that up, but you want to look at the number. Your favorite number is when this number is over 1 or less than -1, therefore that's impossible and there will be no triangle. That's what we want. That's our favorite problem. All right, lost my calculator somewhere. Sorry, guys. Oh, fiddlesticks. All right, on mode. I'm ready. So sine 38 second angle degrees, 40 second angle minutes, or you could have went 38 plus 40 over 60 times 11.8 divided by 9.72. Oh, bummer. 0.7584. Do not delete that number. We're going to do a reference angle. So basically, if I introduce the inverse, which I am, if this was a negative, I would always make it positive when I do the inverse. Because I'm the one introducing it, I can do whatever I want. But if you don't use all these decimals in your calculator, things are going to go bad. So inverse sine of the last answer, and I pick up B1 to be 49.331. Once again, stow alpha, let's work our way backwards, Z. See if I can be smarter about it this time. And then we go 180 minus the last answer, and we get B2 to be 130.668. And we're going to stow an alpha y. Don't like stowing in y because sometimes the calculator rewrites it. So let's not use y. Let's stow alpha w. All right. I don't mind working in decimal. Don't worry, I got them stored so I can convert them to degrees, minutes, seconds whenever I want. Okay. Now, you're hoping that this angle plus this angle go over 180, which they did not. So if they do go over 180, that's the one triangle case that I want to work. Didn't work it yet, so we're going to work two triangles again. So I'm in no big rush. So little a was 9.72, big A 38.40, little b1 49.331 Z, and same little b2. Oh, they give you a little. That is 11.8. So no sense in going sub 1, sub 2, because it is what it is. But we do get a B2, which is 38 plus 40 divided by 60, which is, this in decimal, plus Z minus 180 times the negative 1. Careful. Sorry. So this is the reference angle. Where is sine positive? First and second. We got an answer here. We got an answer here. We got our 49.331. And that is angle Z. So 180 minus alpha Z. This angle right here is 130.668. And that's our B2. And I'm going to stow that in W. Stow alpha W. Let me double check to make sure. Oh, I had it already stored. Sorry, I reworked it. All right. So C and little c1, and this is little c1, and then we got a C2 and angle C2. So let's go get them. Let's go 38 plus 40 divided by 60. Let's just put that in stow alpha A. Now we can go alpha A plus Z, alpha Z, okay, plus alpha A minus 180 times a negative 1. That one is C1 there, 92.002. Stow the Now let's go A plus B2 to find C2. That is W minus 180 because of the triangle. And we get 10.664. Stow alpha U. And now we have to use side finder. Now it's sine A, side finder, side on top, 9.72 equals C1 over sine C1, which is V, which is C2 over sine C2, which is U. And to find C1, you cross it up, and to find C2, you cross it up. So you go 9.72 times sine alpha V divided by sine alpha A, and therefore C1 15.54776592, and then reselect. In the set of a V, we have an alpha U. C2 2.87897897311. Once again, I got all my decimals. How's our lecture coming along? 30 minutes. Okay, no problem. This one is right out of the book. It's question 43. B, 74.3. Little a, no pair yet. 859. Sorry, that's a 5. Little b, okay, law of sines, 783. We're going to go find angle A. So sine A over little a equals sine B over little b. And you bring that up and you take a look at the number. You're hoping it's above 1 or below -1. Sine 74.3 times 859 divided by 783. Oh yeah, 1.0561. Impossible, because sine, the graph sine, bounces between 1 and -1. There's no way it can equal 1.0561. Therefore, no triangle. Therefore, no triangle. New favorite problem. Give me 20 of those. I'll do them all day long. Oh, yeah, last time I didn't convert all my minutes to degrees, minutes, seconds. I'm sorry about that. Take all those answers, all the angles, and go second, angle, convert degrees, minutes, seconds, and you'll be good. The book isn't being real helpful here. Looking for another degree, minute, second one with one triangle. But I do need a one triangle case, so it's more important that I get one triangle. So B, this is 46. Angle B is 113.72 degrees. A, 189.6, therefore not quite law sines. And then boom, there's a pair, and that's going to be a 43. And these are both in yards, degrees. So you're going to get after angle A, so sine A over 189.6 equals sine B over little b, 243.8. And you cross that up and you take a look, hoping that it goes above 1, below -1. But I'm sitting here looking at the solution key, and it says there's one triangle. So, we're going to get an answer between that times sine 113.72. I'm not going to keep typing that thing all problem long. Divided by 243.8. Enter. 0.7119. A1 is inverse sine of the last answer, and you get 45.397 stow alpha z, and A2 is 180 minus alpha z, and you get the 134.602, but there's no way you can take this angle and form a triangle, because they go over 180. Therefore, that guy's out. Therefore, you only got one triangle, which is great, because now we're almost done. Because we got angle A to be angle Z, and we got little a to be 189.6, and we got angle B to be angle B, and we got little b to be 243.8, and angle C is a joke. So let's get that 113.72 STO alpha B action going. And we know angle A, which is really alpha Z, plus alpha B minus 180 times the negative 1, that's 20.88. Here, I guess I'll go right here, 20.88 degrees. But let's actually stow that in C, stow alpha C. Now we just need little c. No sense going C1 and C2 since there is no A2, so let's call it C, and go side finder. But you know your pair that was originally given is the B's. So we know if you're going side finder, it's 243.8 over sine B equals C over sine C. Just cross that up, you're going to be done. So you're going to go sine alpha C times 243.8 divided by sine alpha B, and to get .92407.944. There you go. Did them all. There's all sorts of great applied problems, but draw your triangle. Just keep cranking through this. This is as hard as it gets. Remember, the two triangle case is kind of painful. And by the way, if you do want to convert your angles to degrees, minutes, seconds, before I hang up here, so, you know, angle C was this, 20.88. Just goes second, apps, DMS, enter, and you would say 20 degrees, 53 minutes, because this number is over 30s. So this would be 20 degrees, 53 minutes. So that's all I ever do is I roll my answers. You know, at the end, I go degrees, minutes, seconds, degrees, minutes, seconds. And once again, if this number is over 30, you round up. If it's under 30, you keep the number. Since 58 is over 30, go with 53. That's all I got for today. See ya. Once again, it's time of year. Should you get some text? 720-985-1986. Text me. Make sure you tell me who you are. I'm a pretty reasonable guy. I don't mind making extensions. You know, it's tough taking an online class. All right, so give me a call, give me a text. Expect quite a few of you to be like, please extend this. Give me some help here. I'm very available, so that's what we got going. See you later. Bye.